this short video, we have a simple task. One person has issued 23 receipts. From those 23 numbers, we collect 23 first digits. For example, the first receipt has a value of $1,927.48, and we collect 1 because the first digit is 1. Our hypothesis is our data follow the Benford Law. Then, what is the Benford Law in the first place? So actually, Benford Law is also called the first digit law, which gives the different frequency for 9 first digits. Conventional wisdom tells us all 9 digits should have the same frequency, 1 over 9, or 11.11%. However, according to the Benford Law, the lower is the value of a digit, the higher is its probability. For example, for the first digit, digit 1, its probability is 30.1%, which is much higher than 11%. For the second digit, its probability is 17.6%. This part is a formula review. So actually we are going to discuss the power of 10 and log 10. And make it easy, we start from the simplest one. The first pair is plus and minus. The second pair is multiplication and division. The third pair is power of 10. So 10 is base versus log 10. Last pair is exponential function and natural log function. Next, we are going to use the Excel to show 4 pairs. Okay, and for the Benford Law, we pay attention to the third one. Okay. However, we start from the simplest one, plus and minus. Suppose we have a equals 5. Okay, we have extra value of 2. Then the b equals a plus 2. Then we have a value of 7. Now from this 7, we want to recover a is simply b minus 2. In this sense, plus minus are a pair. So let's look times and division. Suppose we use a value of 10. Okay, so this is 3. So b equals a times 3. Obviously it's 30. And from b we want to recover a is simply b divided by 3. In this sense, times, multiplication, and division are the second pair. So let's look at third pair. This is the focus of this exercise. Okay, and suppose let's use a value of 2.5. Okay, so this is 10, and so this is power of a. So the 10 power to 2.5, we have $316 to A. Okay, from B, if we want to recover A, then we use log 10. So this is log 10 function is B. Then we got 2.5. So this is extra exponential function versus natural log function. Okay, so we randomly choose a number 3.5. So this is exponential 3.5 and 33.1155. Okay, if we want to recover 3.5, then we can use natural log and b. Okay, natural log b. So let's look at the frequency of 9 digits according to the Benford Law. So 1, 2, So we have 9 digits. So this is Benford Law. So this is log 10. So this is I plus 1 divided by I. Okay, so this is 30%. Okay, then we copy and paste. And we know the total summation of all the probability should be 1. Then we got 100%. At this moment, please pause this video to get the data. For all my courses, hands-on is very, very important. And I list 3 methods to get the data. The first method probably is the simplest one. Just Google the following phrase. Later I'm going to show you how to do it. Method 2 and method 3, you can either download a text file or Excel file from my web page. In the trial of the state of Arizona versus Wayne James Nelson, the defendant was accused of issuing checks to a vendor that did not exist. Okay, so this is our data. Just copy and paste. Then we launch Excel to paste it there. These are the steps we are going to take to test, do those 23 first digits follow the Benford Law. Step 1, we get data. So actually we did already. We copy and paste the data to our Excel. Okay. Step 2, find the first digit by using Excel left function. Step 3, we use COUNTIF. We generate 1 to 9 to find the count for each digit using the Excel COUNTIF. So actually, eventually we have N1, N2, up to N9. Suppose N1 equals 5. So this is mean digit number 1 appeared 5 times. Step 4, we generate probability. So PIB according to the Benford Law. And again, we use log 10 function. Okay. Step 5, we calculate expected count. So this is NI versus, so this is count is from our data. So this is count according to the Benford Law. Okay. Then we calculate deviation. So actually step 6 is critical. We calculate deviation. So this is our, so this is, for example, 1. I equals 1. N is count. How many? 1. So this is N1B. So this is based on the Benford Law. How many 1 we are supposed to have divided by NIB. Step 7, the summation of all these deviation from step 6. Step 8, the summation follow a chi-square distribution. So actually we compare the summation with the critical value. So if the summation from step 7 is higher than critical value, we reject our null hypothesis. Otherwise, we accept or fail to reject. To calculate, assume our significance level is 1%. To calculate critical value, we use Excel CHISQ inverse RT. RTs mean right tail. 1% degree of freedom is 9 minus 1. As the first step, we need to separate this data into different columns. So if we look at this cell, we know for this cell we have different values. Okay, we highlight this column and click data and text to column. Okay, then we choose delimited, and I use dollar signs. Okay, so this is other. I choose other. I use dollar signs. Okay, because I have two purposes. One, I use dollar signs as the delimiter or separator. The second purpose is I can remove all the dollar signs. Just click finish. Then we highlight them. Okay. Then you can then separate into different columns. Okay, so this one is quite special. Okay, so I'm going to use the red one to show it. So if you know the Excel well, you know, you see if these are numbers, it's right aligned. Obviously this is text. Okay, and then alternatively we can use count. So this will count our values. Okay, numbers. Okay, is 23. And if we use count A, so this will count both numerical and character. So if we just highlight, okay, then we have 23. Okay, if you look at this value, clearly we see 2 decimal points. You can modify it. For this exercise, it doesn't matter because we are going to pick up the first digit. As our first step, we are going to collect our first digit. Okay, so we use Excel left. Okay, you see it treated as a text. So this is first number. So we are going to collect the first one. So this is 1. We copy our formula 1, 2, 3, 4 and paste. Then we collect our formula. Okay. So next step, we type 9 digit. Okay, so this is digit. And so this is our n. And how many is like frequency. Okay. Then we use count if. The first one is this range and equals to 1. We can manually count, check. Yes, 1 only appear once. Okay. Before we copy and paste, we have to fix our range by hitting F4. It's dollar signs. Okay, so this is, and to double check, then we can use summation. So this should be 23. So our total number. Okay. So this is probability based on the Benford Law. Based on the Benford Law, as we know, we are going to use log 10. So this is log 10. 1 plus 1 divided by 1. So this is our frequency based on the Benford Law. Okay. Then we can also check summation should be the same as 23. Sorry, it's 1 probability. Okay. So this is our count and count I based on the Benford law. Based on the Benford law. Okay. So we know, suppose we have 100 numbers, is 30%, then we get 30. So probability times total. Okay, we fix the total. Then we copy and paste. Again, so this summation should be 23 because we have 23 first digit. Okay, so this is a deviation. So this is deviation we discussed. So this is n1 minus n1 based on the Benford law squared divided by n1. Squared divided by this one. Okay. Again, so this is n1 based on our data minus n1 based on the Benford law squared divided by n1 based on the Benford law. So this is formula. Then we copy and paste. And so this is our total summation. Okay, so this is our summation equal sum. Okay, so this is our total value. Okay, assume we have alpha equals 1%. So what is the critical value? The critical value we use CHISQ inverse right tail. Okay, so this is Excel function we are supposed to use. Okay, so this is a probability is 1% and it's 9 minus 1 because we have 9 digit. 9 minus 1. So this is our critical value. Okay. So this is our chi-square statistics. So this is our decision rule. Decision rule is if our chi-square value is higher than or equal to critical value, we reject. Otherwise, we accept or fail to reject. Obviously, we reject. Okay, so this is decision rule based on the chi-square value. Okay, and decision also can be based on the p versus alpha. Okay, so if p is less than alpha, we reject. Then how to calculate p value? So this is CHISQ DIST. Again, we use right tail. Okay, so this is the chi-square test statistics. Again, degree of freedom is 9 minus 1. So this is our p-value. Again, so this is our p-value. Okay. Then our decision rule is if p is less than equal to alpha, we reject. Otherwise, we accept or fail to reject. You see, we have the exact same conclusion. Okay, because p-value is so small, it's almost 0. After finishing watching this video, I have several challenging tasks for you. The first one, using Excel rand between function to generate 5,000 random numbers between 1 and 1,000. Test whether they follow the Benford law. I have a note here, how to generate a fixed set of values. For example, you tell John how to generate 1,000 fixed value. Challenging task number 2. Download the height of the tallest building, a dozen tallest building in the world, and test whether their first digit follow the Benford Law. Challenging task number 3. Download about a dozen companies' several years balance sheet and income statement. Test if their financial statement follow the Benford Law.